Chapter 9, Carbonyl Compounds, Part 5. Chemical properties of carbonyl compounds. At the end of the lesson, students should be able to explain the chemical properties with reference to iodoform, explain the identification test for aldehyde and ketone using 2,4-dinitrophenylhydrazine, Tollens, Fehling, Benedict, and Schiff reagent. The first identification test, known as Brady's test. The reagents, known as 2,4-DNPH or 2,4-dinitrophenylhydrazine. This reaction involving elimination of water, at which, on the first place, we need to remove oxygen on the carbonyl group, and next, removing 2 hydrogen that bonded to the nitrogen atom. The remaining structure, we will write it on the carbon double bond. This test will give a formation of yellow or orange precipitate. The same thing we apply on a ketone. Remove the oxygen atom that bonded to the carbonyl group, removing 2 hydrogen that bonded to the nitrogen atom, and the remaining reagent, we will write it on the carbon double bond. Reactions on ketone will give a same observation, at which a formation of yellow or orange precipitate. Brady's test is a test that detects the presence of carbonyl compound. It will give positive result for all aldehyde and ketone. The next identification test, known as Tollens test, this is the reagents. During a reaction with aldehyde, the CHO of aldehyde will turn to COO-, known as carboxylate ion, together with silver mirror or grey precipitate. The R on the aldehyde can be alkyl, aryl, or hydrogen atom. Ketone, using the same reagent, nothing is happened. As a result, no formation of silver mirror or grey precipitate. Tollens test is a test that differentiates all aldehyde from ketone. Next, Fehling test. This is the reagents. For aldehyde, we will see the same product just like Tollens, at which the CHO group of aldehyde will turn to COO-, the carboxylate ion. And together with the observations of Cu2O that give formation of brick red precipitate. The R here indicate alkyl or hydrogen only. For ketone, if we use the same reagent, nothing is recorded. No formations of brick red precipitate. Fehling test is a test that differentiates aldehyde from ketone and differentiate aliphatic aldehyde from aromatic aldehyde. Fehling test using a complex ion known as copper 2 tartrate. Benedict test using the same reagent as the Fehling test, showing a same reaction as a Fehling test. The CHO group for aldehyde forming carboxylate ion of COO-, give the same observation by formation of Cu2O, give same observation formation of brick red precipitate, at which the R here indicate alkyl or hydrogen. And if we use the same test on ketone, no observable change, and no formation of brick red precipitate is recorded. The difference between Benedict's and toluene's is due to the complex ion, at which for Benedict, the complex ion that being used here is a copper to citrate. Shift test using a shift reagents. It will give positive result with all aldehyde, either alkyl, aryl or hydrogen that bonded to the CHO. The observation, formation of pinkish purple solution. Ketone. Shift test will give a positive result to the one and only ketone that we call as propanol, and negative result to the rest of ketone. Iodoform test. The reagents iodine in hydroxide in aqueous condition. The function of iodoform test is to detect the presence of methyl carbonyl group. This is the structure of methyl carbonyl group. At C double bond O carbonyl, we need to have a group of methyl. Reaction with aldehyde. Here we use example of ethanol. As we can see on the structure of ethanol, there is a methyl group. The methyl group on this ethanol will come out as triiodomethane that give a formation of yellow precipitate. The remaining HCO will forming carboxylate ion. For aldehyde, iodoform test only give positive result for ethanol. Ketone, presence of methyl group on the structure of ketone, we produce triiodomethane. At the end, show a formation of yellow precipitate. The remaining RC double bond O will come out as the carboxylate ion, at which for ketone, it can either be aromatic ketone or aliphatic ketone, as long as we have presence of methyl group that bonded to the carbonyl C double bond O. The end of part 5.